Imagine diving into a quiet, overgrown marsh, pushing past the duckweed, and focusing your gaze on a single submerged strand of pond algae. To the naked eye, it looks like simple slime. But if we amplify our vision 1,000 times, a structural masterpiece emerges. You are no longer looking at random muck. You have entered a sprawling micrometropolis of architectural wonders. Anchored to the algae are rows of elegant, transparent vases, each housing a delicate, living occupant that behaves like a jack-in-the-box with a microscopic intellect. These are the loricae ciliates, specifically from the fascinating sister genera Thuricola and Vaginicola, commonly known to microbiologists as sheathed or dwelling ciliates. To comprehend the scale of these magnificent architectural organisms, we must step entirely out of our human experience. A typical Thuricola or Vaginicola housing structure, scientifically called a loricae, stretches to about 150 to 200 micrometers in length. If you were to stack 5 of these glass-like tubes end to end, they would barely span the width of a single grain of table salt. Yet, within this microscopic boundaries, they engineer fully operational homes. They thrive globally in both freshwater ponds and marine coastal waters, permanently cementing their protective cases to submerged plants, rocks, or any stable debris where the water currents flow freely. When you observe Vaginicola or Thuricola through a microscope, their physical appearance is nothing short of breathtaking. They feature an elongated, trumpet-shaped cell body anchored deeply at the bottom of a transparent, cylindrical vase. At the top of the cell body sits a beautiful, ring-like crown of rapidly beating cilia. By spinning these hair-like oars in a perpetual rhythm, they create powerful microscopic whirlpools. This vortex vacuums in their primary diet, swimming bacteria, tiny flagellates, and organic detritus. They are the supreme filter feeders of the microbial shallows, converting free-floating organic waste into metabolic energy. But what truly separates these two sister genera from ordinary microscopic life, and from each other, is their spectacular mastery of defense engineering. When a predatory microworm or a turbulent current disturbs the water, the ciliate instantly contracts its body, snapping down to the very bottom of its protective tube in the blink of an eye. If you are looking at Vaginicola, it relies purely on deep retraction for safety. But if you are looking at Thuricola, you are witnessing a profound evolutionary leap. It possesses a literal trapdoor. Attached inside the tube is a delicate, hinged valve made of hardened organic material. The moment the cell pulls back, this tiny internal door snaps shut automatically behind it, completely sealing the entrance like a medieval castle gate under siege. For us humans, these armored architects are completely harmless. They are not dangerous pathogens that disrupt our health, nor are they active probiotics utilized in our food industry. They are entirely neutral, benevolent neighbors that act as natural water purifiers. By consuming massive quantities of suspended bacteria, they help clarify our natural waterways and stabilize the foundational layers of aquatic food webs. Perhaps the most fascinating insight into their existence is their profound relationship with green energy. Many species of Thuricola maintain a mutualistic symbiotic relationship with Zoochlorella, microscopic green algae that lives safely inside the ciliate's transparent body. The ciliate provides the algae with a protected home and a front-row seat to the sunlight, and in return, the algae share the sugars they produce via photosynthesis. It is a microscopic, solar-powered partnership that allows the ciliate to survive even when bacterial prey is scarce. Ultimately, Thuricola and Vaginicola remind us that engineering, defense architecture, and complex ecological relationships are not inventions unique to human civilization. Half a billion years before humans built the first walled city or designed a mechanical valve, these single-celled wonders were already crafting their own microscopic fortresses, proving that the drive to build, protect, and harmonize is woven deeply into the very fabric of life itself.